In this video, we're going to take a look at this first example from this section, which is just an extension off of what we did in the very first example in the last video. We're still taking a look at the same sample of 500 children, 250 boys, 250 girls, and asking them what their favorite color is. And as I state down here, let's suppose that a toy manufacturer believes the color preference of a child is independent of their gender. Assume that all this data was collected with a random sample, and can I perform the appropriate test using a 1% level of significance? Okay, so let's go ahead and get started here. My hypotheses are going to be pretty easy because, again, they'll say that the variables of favorite color and gender are independent, and in H1, the variables of favorite color and gender are dependent. Keep in mind that H0 is always going to have independent up there, and it always means that these variables are not related, whereas in H1, we're saying that these variables are related. Okay, so let's see how we would actually go ahead and do this. For my test statistic, I'm going to go ahead and I'm going to have to enter my data into a matrix. And I'm going to show you how we do that on the calculator. That'll be important because we're going to need to see several things on the calculator in order to run the test, but also in order to complete our checks in the next step. Okay, so let's switch over to our calculator and see how we would enter this data into a matrix. The data that we're going to be interested in entering is only the data that we observed here that excludes the total values. Okay? So only that data that's boxed is the data we're going to enter. So let's quickly see. If I go to my calculator, I can go ahead and see that if I look right below the math button, there should be an X with a power of -1 on it. And in blue or maybe in yellow on your calculator, you should see the word matrix. So I'm going to click second and then that particular button. It should pull up a menu that looks something like this. What I want to do is I'm going to go over to edit, and I can just click on the first matrix. It'll always just be easier if you use the first one. What I can do here is, regardless of what my screen looks like now, I can kind of set how big of a box I want to actually attempt to work with. And I want a box that's going to look exactly the same size as this. The first thing that the calculator is going to ask you for is how many different rows you had. So here we're going to have 2 because we only had boys and girls. And then it's going to ask you for a number of columns, which in our case will be 4. So notice if I do 2, enter, just 2, enter, and then 4, enter, I get kind of a grid set up just like we had on the If I was then to go ahead and take a look at how I could enter this into the calculator, I would start by just typing in the values exactly as I saw them. So I had 107, 85, 33, 25, 93, 65, 67, and 25. So I have all these values entered into the calculator. This is great. Okay. Now, what I'm going to go ahead and do here really quickly is to show you what you will need to do in order to be able to go and verify the checks appropriately. Once I have these values, I can go to Stat, over to Tests, and scroll up. I want to look down for this chi-squared test. When I click on this, I want to look at what is observed. Notice this says that my observed values I put into a matrix labeled matrix A. The calculator here is telling you that it is going to put for you the expected values into matrix B. So you don't have to worry at all about changing either of these two values, nor do you have to worry that you didn't put anything into matrix B. The calculator is going to fill in these values in matrix B. Notice that once I go to calculate, the test will be run, and I should have numbers that look something like this. Now I'm going to ignore these numbers for the moment, and I'm going to go back and take a look at that matrix menu one more time. So I'm going to click on second, go to that matrix menu, and I'll notice now that a matrix B has been added, and it's got the same size as my matrix A. If I go over to edit and I click on matrix B, I can see that I have here all of the values that I would have expected. And you might notice that these are the exact same values that we computed by hand in the last video. But these values are important because this allows us to not have to compute these values by hand. And they're also important when going ahead and checking conditions. So let's go back to the problem and see if we can check our conditions now. Okay, if I go back to the previous page where everything had been summarized for our test, we should be able to see what some of our checks were. Our first check is that we had counts listed in our box of values up here. We don't want percentages of people in categories, we want the number of people. And so that seems pretty easy. We definitely had numbers, not percentages. Number 2 said we had to obtain things via a random sample. And the sentence up here says, assume that the data is collected with a random sample. So that's pretty safe. Check number 3. All expected counts are greater than or equal to 1. Well, these are, again, not my expected counts. These are what I observed. To see what I expected, I have to look at what matrix B told me. And definitely all of these values are greater than or equal to 1. And all of them are even greater than or equal to 5, which will be important for the next check. So down here, all of these are greater than or equal to 1. All of them are greater than or equal to 5, so no more than 20% are less than 5. That is also checked. And finally, check number 5, we definitely sampled here without replacement, so we have to check if 20 times our little n is less than or equal to big N. This, of course, would mean that we have something like 10,000 less than or equal to n. So we surveyed 500 children, and we just want to know if the total number of children is greater than 10,000. Well, if I'm thinking like children in the world, yeah, there's way more than 10,000 children in the world, so this also seems perfectly valid. Okay, now the last thing I can do over here is get ready to write down my chi-squared value that the calculator will tell me. I'll also go ahead and get ready to draw my chi-squared distribution. I know that it has a nice skewed right sort of a look. And I'll get ready to set up my p-value as well. I'm going to go back to the calculator and rerun the test. Please ignore that. So if I go and I take a look here at my chi-squared test, and I just rerun it again, no big deal, I'm going to write down these values. I get a chi-squared value of 15.2067. So a chi-squared value of 15.2067. I can put that on my number line in relationship to 0. And I can see that I can shade in my space here. I'm always going to be doing a right-tailed test. And so this up here corresponds to my p-value. So that should be the probability of getting a chi-squared that is greater than 15.2067. Okay, so that's good. The calculator tells me that that value is 0.0016. 0.0016. I can now see, based on my alpha value in this problem, my alpha value is 1%. So is this bigger or smaller than 1%? Well, my alpha here should be larger. My p-value is the smaller bit. So I have a rare sample, and that should lead me to reject H0. So I can state my conclusion in the following way. I can say that getting a chi-squared value of 15.2067 is rare to get by chance if H0 is true, which means if the variables are independent. So it's rare to see what we saw if the variables are independent. So therefore, we have reason to believe that the variables are not independent or are dependent, meaning that there is a relationship between gender and favorite color. That means if I know someone's favorite color, I might be able to maybe guess more accurately than not what gender they are. And if I knew what gender they were, I could probably guess with more accuracy than not what their favorite color is. So we can see there's a relationship between these values. So this is how I would go ahead and complete this test. Hopefully this doesn't seem too strange. It should be very, very similar to all the other tests that we've done, with just a few minor modifications in terms of working with this new matrix. In the next video, we'll take a look at example number 2 to try to just see one more example of how we would work with a test like this.